Hello, everybody. Thanks so much for the nice introduction. I'm very happy to be here today at the JNIPER Coffee Hour to talk about bridging art and quantum science. So I'll jump right away into the menu. So what kind of awaits you for this talk? So I'm going to start with a very short introduction, about who I am and what I've done, maybe a little discussion about art versus science. And then I'll go on to a first part because I wanted to share what I've learned from doing art and science through also project examples that we've developed here at the NCCR SPIN. And then a part two, which is going to go more into the making of those projects and how we do it and how it can give maybe ideas. As Meg said, it's a discussion, so feel free to interrupt me at any time. And if you have a question or to make a comment, anything goes. So my name is Marie Dantec. I'm both a scientist and a designer. I've done a master's in nanotechnologies back in time. And then I did a PhD in material science in Switzerland at EMPA and EPFL on 3D printing of materials. And then at the end of my PhD, I actually wanted to take evening courses in illustration and desktop publishing because that's something I was really interested in. So I started actually doing that until the end of my PhD, where I decided that I actually more professionally wanted to go into this topic and switched a little bit my path from being a researcher to getting into visual communication masters also in Switzerland. So I've stayed in Switzerland for a pretty long time. And after that master's, I decided that maybe I'll be the most useful at not on as just a researcher or just a designer, but at the crossroads. And I started to do more science communication when I was hired at the NCCR SPIN as a communication outreach officer. Just briefly, what the NCCR SPIN is, it's actually a consortium of research laboratories working with a G on spin qubits for quantum computing. So we have a broad network of institutions working on different aspects of the development of these qubits, ranging from material development to qubit architecture, to software, to theory. And all of these groups actually collaborate to develop a practical, scalable quantum computer made out of silicon and germanium. So when I did my transition from science to design, I just wanted to give you a few of what I experienced. It's more personal observations. So I first I noticed that so the question is there a difference? So science and design actually have both want to find solution to a problem through experimenting and somehow, and they both have clear objectives to reach. But in my opinion, they had different ways of reaching those objectives and finding a solution to a problem. So in science, I always had the impression that my quest was for the right answer, the thing that is reproducible under a certain frame, and that it had to be objectively correct. Science also has a lot of objectivity brought into it, even if it's up for debate, but this would be another discussion. And I learned mostly that I should inspect everything before making an opinion. So I should weigh all the possibilities, check literature, etc., before I can actually make sense out of it. In design, when we started finding a problem, we found we have always multiple possibilities. If you give the same problem to different designers, they'll give you different solutions, all working probably, but just all different. It's more subjective in that way and more human oriented. Input more of yourself into it. And the most, I think for me, one of the most valuable skills I've learned in design school was learning to do. I've seen my colleagues tackling the problem by starting doing prototypes, starting testing their ideas right away on the paper, drawing something, and iterate until they found a solution. And it's something that I hadn't done so much as a scientist. I had tendency to think first in my head very, very much and think that I could just do it once I've thought about it enough. So for me, these are the differences that I found between science and design. And then I find art a little bit different from design. And I wanted to ask an open question to start. What is for you the main goals of art, or what is art? I think, thank you. I think for me, it's also really that it makes me feel, it makes me think, and it's deeply human in this way. It has reflection. You can have reflection in society, you can express yourself, can talk about emotions. There are subjects that we all kind of think about. And I find that it unites us in a sense also that everyone can say something about a piece of art, and also everyone can kind of produce art as well. And in both directions, no pre-knowledge is actually required. So it's a platform that could put everyone together on some kind of the same footing in a way. And with that, I want to transition to art and science by inviting you to different breakout rooms for about 5 minutes. And maybe you can share with each other an example where you've seen recently or not recently an art and science intersect in daily life in any kind of medium. And maybe try to discuss what struck you about it, what attracted you to it, what did it work for you or not. And maybe discuss about what you liked and disliked about this intersection. So I think everyone's back, and I hope you could have like a good talk about your last art and science piece that you've seen around. So we'll go further if I can. Yes. So following that, I'm going to start sharing with you what I've learned doing art and science also at the NCCR level. And this is same thing here. If you want to interrupt me at any time, please do. Yeah, it can be also a discussion. So as some of you also said before, and I started also to talk about it, the first thing I've learned is when we bring science as an art piece first to the public is that the emotion coming from the artwork can be used as a common ground to start with. So if we start with a subject that everyone can relate to, we can get people to be drawn into the science we're presenting. So the example I have here is an artwork that we developed with a team of 6 scientists that we presented and this time in all of these pictures, it was in Genoa in Italy, but it was first designed for the Berlin Science Week in Germany. And our idea was to make a 3D structure and that has the shape of an hourglass, roughly. And from the top here on the picture, I don't think we can see very well. Maybe here on the photo a bit better. It has like beads coming from the top that represents the time that we put into producing data and the effort. And then at the bottom, it transforms into a huge amount of lost data. And so what we wanted to, so each panel is actually designed by each scientist from their own lost data that they were working on. So it can be pieces from the lab, but also measurements that went wrong, notes, anything that they would use to produce their own data. And the idea was to show or to introduce the public to like failure also in science, that we also fail so much before we can get one good result, and to show also some of the problematics that we can have doing science. And the fact that we actually started with talking about failure in science, at least it was very visible in this event, made people come in and ask more questions and relate to to that first at a human level, and then we've observed that they started wanting to know what kind of principles were behind each of the panels, how they were made, and they started asking for more science questions as well. So starting with an art piece enables a form of dialogue as opposed to a lecture, which is sometimes something that the public is maybe dreading in a way, because as scientists we sometimes want to teach, but are less into a dialogue, and art can really bring this dialogue form. And it can also bring a sort of vulnerability, because the scientists are also trying out to do an art piece, which they're not usually used to. And so they're bringing something out of their own comfort zone, which is also like showing a step toward an audience. And so it's really reciprocal. And so we've had here we've had on that occasion some testimonies that are also related to that idea. So normally in science, we always focus on the most striking results, but this thing, the errors, I think it's the human side of science, and starting with that really enabled us to go further and talk about science. The second thing that I've learned is the power of weirdness. So I wanted to ask you, what do you think is the most first sentence that we hear when we show an art installation? So actually, a lot of the time people was like, what is this thing? So it's more like they just didn't know exactly what it was. Some people also came saying to us that they found it beautiful, and that's how we started a lot. But a lot of the time it's just like, can you explain what this thing is? And so people are attracted by odd things that are standing out. So whether it's in the middle, like here in the middle of an institution, or at a science fair, or anywhere else, actually, if you bring an art and science piece, it usually catches the eye because it's the odd, kind of an odd thing, or an out of the box thing in the middle of the event, right? The third thing that I've observed is that it was super important to bring the scientists that made the art, especially if they made the art, to the event as well, because they get really enthusiastic, obviously, about what they've done, but it really finishes the connection, the human connection, and they are here to explain what they had in mind, and they can answer deeper questions. And Aldo, this guy here, has done a lot of outreach with us, and is very enthusiastic. And actually, when I read all the testimonies about Aldo, because we asked people to write their impression into a notebook, a lot of impressions were about this guy, because he was very enthusiastic. And the more, of course, the more you can convey that, the more people also get drawn into the piece. The fourth thing is something I actually already learned in when I was in art school, and it's define your audience. Otherwise, the risk is that you don't get anyone engaged. We have a tendency to, I mean, for me as well, to think that if we have one chance to reach an audience, we want to design for everyone, for a general audience. But there's not really such thing as general audiences. And even if you have one booth, we kind of have to make a choice to whom is the booth addressed to. And it's more difficult to do than to say, of course. But that's what, for example, we try to do at the Berlin Science Week campus part of what we call campus. It's a project. We had a booth it's a bit less art, maybe more science communication, where we designed 6 panels, and these were actually for more adults and science enthusiasts. We also designed like an interactive boards where people could play and see the difference between bits and qubits for themselves. One of our researchers designed this interactive board, but then we couldn't really appeal to kids. And so this year, actually, a new team of scientists designed new tools for kids. So they added a wheel here with questions that the kids could spin, and then a question would appear for them to answer or for the researcher to answer. So that started the dialogue as well. And one of our PhD students invented a story, Aripriya Gani. She invented also a quantum story of like maybe 10, 16 pages, where a main character is going into a quantum lab and is experiencing quantum phenomena. So this was actually quite appealing for kids, and all of the notebooks that we had produced actually went away in the 2 days we were at the fair. So just to show that, yeah, we can, even when you have one booth, you can appeal to different audiences, but then you have to make probably different materials. And another example of that was actually when we designed Save the Cat for the APL Global Physics Summit in 2025. I don't know if you were there last time, but we were commissioned or asked, I don't know, to design a kind of a quantum quest for the International Year of Quantum Science and Technology. And the objective was to share quantum science and history of quantum science to the scientific community that was there at the APS, and through a semi-digital treasure hunt. And we knew, so this was designed with Joel Hutchinson and Marilena Longobardi as well. And we knew that at the APS Global Physics Summit, a lot of the people are also very busy in meetings, in networking, etc. So we actually wanted to target more of maybe an audience, younger audience, maybe PhD students, postdocs, people who would get an interest in those kind of games, because it's still quite demanding. And we really tried to make a story and riddles that were targeted to this type of audience. So people who would want to play games, and through playing that game would learn something about quantum physics. So it was for physicists, sorry. And we wanted equal representation as much as possible. And the objective was also to learn about quantum physics and quantum physics history. So for example, we would actually share quantum physics history. For example, this riddle was called Mixed Signals, and was talking about the first transistor. So we shared the design of the first transistor through the riddle, and then people had to guess which letter it corresponded to with on and off letters. So 0, 1, 0, 1, 0, 0, 0, 0, etc. corresponds to, I don't remember which letter actually, and then solve the riddle. And then once people had solved the riddle, we would share also a piece of quantum history with them. So through wanting to play the game, they would learn about quantum physics. But the first objective was to draw in people who would actually want to play such game. And maybe we had few teams getting into it, but they were really engaged. People really got to the booth, and sometimes just to tell us that they really appreciated the game, and that they were super enthusiastic. Some people told us they were supposed to go to a bar, but instead stayed here until 1 a.m. to finish the game. So this was very rewarding to us, and really comforted us in the fact that we had targeted the right audience. As a fifth point, I wanted to go into science and storytelling. And that's something maybe that personally I've been seeking out for quite some time in science communication, is how to integrate science into a story as opposed to explaining science. So there are a lot of fantastic books about that are sharing quantum physics to lay audiences, either through pure text like this one by Julien Bobroff, or in a comic book. For example, Quantics by Laurent Schaffer does that very, very nicely as well. It's more for adults. And then for kids, we have very beautiful books about quantum physics. This one, for example, my first book of quantum physics, is actually very visually stunning, and quantum physics for babies. Now, Now these books get into quantum physics more in an explanatory way, and I wanted to explore ways to engage other types of audiences, but through storytelling first. So that the story comes first, and they by being into the story, that they would learn about science. And that's especially how we wanted to engage, especially children, in that way. There's one book that I found that was starting to do this a little bit. This is for adults, definitely, but it's the story of a boy who lost his dog and then goes to a quantum physics conference, gets sucked into his seat, and then is meeting all of the big names of quantum physics, and then understands how to get his dog back, basically. That's one example of that, how this can be integrated. And we try to do that also in some of our projects. Save the Cat was also one way to do this, by making the audience the main character of the story. Because maybe I forgot to tell the story about it, but because you're the scientist, you're a scientist actually who wants to make a time travel portal. And as every experimentalist, you have stuff lying around in your lab, and by accident, poof, you just get into your own portal, and the problem is that it's not really finished. So you have to solve riddles to come back to 2025. And by being the main character in the story, you're also much more engaged because you're an active participant. In an attempt to do that as well for children, to have science being part of the story rather than explanatory, I've made a book also within the NCCR frame that's called Icebreakers. And the main character is a molecule of water. Of course, we don't say it's a molecule of water, it's just a character. And this character will start being like in a crystal. He's kind of bored because nothing's moving, and it's been like this forever. But then suddenly the world starts to crumble. Everyone starts to be together, to slide, to fly, and they go onto a journey until you discover at the end of the book that it was kids playing with water, evaporating water in their pan. So at the first read, you can actually read the book. The idea was that you can read the book without knowing anything about science, and it still would be a story. And then at the end of the book, there's a page or two about science. And you can read the book a second time with that knowledge, and have a second layer of reading the story. So that was one attempt to have science really being the story instead of explaining science, if that makes sense. And that's one of the, this was a lot of molecules to draw. And the last point that I've learned, and it's not the last point, but one of the main points that I've learned, but is that our audience is actually everywhere. Not only at science fairs, because of course you'll find a lot of the science enthusiasts at science fair for sure, but we can talk about science in different contexts, and particularly outside of science fairs. For the past 3 years, we've been partnering with a comic festival in Lausanne, in Switzerland, and we've been doing panel discussions with comic book authors and scientists on the same stage, so that they could have cross talk about quantum physics in this case, or science in general. And we also invite them to art challenges. So I would ask questions, for example, and then the authors would live answer those questions by drawing. So it can lead to a lot of laughter as well, or a lot of questions afterwards. This format has been quite successful in the past years. We've had a lot of questions as well from the audience, and that was not first a place where we could necessarily talk that is dedicated to talk about science, but where you can talk about science, and then we find also a different audience that also is interested first in comic books, but then they get interested in science by coming there. So now I want to go to part 2, which is more of about the making, how we chose to make that happen in our institution. We do mostly collaboration. So I'm going to mostly talk about the collaborative work with the scientists, because I think this multidisciplinarity is, for me, very important, and this is also, when you're in an academic frame, one of the cores, I think, of making science communication is to involve the scientists in the art and science. But first, I wanted to talk about how we look at data. So how do we transform data into art in a way? I think there are many ways to do that. And maybe there are different ways to look at data. So there's the scientific approach, the one that we all know. What does the data mean, what it is, what variables are important, what is the scientific message? But then we can also look at it in a different way, with more of an artistic approach. Maybe you start abstracting the data through colors, through shapes. What is that line doing? Can I change the colors? Maybe through emotions. What did the scientists feel while measuring? Can we extrapolate the message and bring also more ideas into that data? How can I aesthetically transform this set of data? Is there another way of visualizing this data? Can I maybe plot it in another medium, paint it? I don't know. So start seeing it in another way. And so as example, for Zhenxing Liu had designed this panel on our hidden variable construction, and she's taken elements from the lab. So she's taken gaskets from her microscope, because she needed to use scanning tunneling microscopy, which requires to be under vacuum. So she took all gaskets that were not functioning anymore, and she took some of her surface data, because she was scanning surfaces and observing very small features on her surface. And then she used actually the gasket as frames, and she colored them in aesthetically pleasing way as well. She added the molecule she was working on, and then she set everything into an artistic composition. So that was maybe one way of transforming her data. Here, if I take an example of theory notes, Pierre Fromholz here has designed this panel, and he chose to cut his notes into hexagons. Hexagons, and that was also embodying a pattern that he was working on at the time. And here I transformed those notes into birds to just also talk about ideas in scientific minds. So there are many ways to transform data. And that's how I want to go to our second breakout room. And I propose to work with this data. You don't really need to know what it is, but this is actually the silicon band structure, which is kind of a map actually that says where electrons which energy electron can have or cannot have, and it tells you if the material is conducting electricity or not, basically. And I'd like to maybe in groups for 5 minutes describe it maybe more scientifically, and then describe it more artistically, and maybe we can imagine how to retransform it. Yeah, we also talked, it was interesting to talk about the fact that even if we didn't understand the data, we could still bring new ideas by actually, even not understanding it, could bring fresh ideas, and avoid being stuck in the scientific meaning as well. So thanks a lot. So I will tell you what I did with this data. But there's infinite possibilities, as Jen suggested also in our session. I was actually this year at the Berlin Science Week, we also had an art and science installation, and we all made lampshades. And I used this as an idea that came up with the team. With the silicon band structure into a lamp. So Actually, it's not super visible maybe on that picture, but the blue thread is actually the bands, the silicon bands all around. And then the light in between can also embody the fact that electrons can jump from one band to another and emit light. And here the global meaning, I just wanted to have some kind of path that embodies the fact that science, going on a science journey is like going on a path. And at every knot, you can have 1,000 million questions that kind of pop out. And the questions are here on the little papers that are dangling. Yeah, so that was the idea behind it. But that's one way of transforming this data. But all of these ideas that you guys had also can be fantastic ways of transforming it. Just a few more examples here. Clément Javert-Zaghali had wanted to talk about the fact that quantum application can bloom out of research. So he 3D printed some of his ideas, the ideas he was working on as a researcher. So heart, for example, heart issues, developing molecules, space applications, and turned them into some kind of flowers as well that he grew from the floor on metal wires. One project is really nice as well. So transforming, we talked about music also in some other sessions, but here it was dance project. Ilan Bouquet, one of our PhD students, developed this dance project with the idea that qubits undergo rotation and phase shifts through gates. So he had qubits as a sequence of movement, and every time he was applying a gate, then the sequence would change accordingly in space. And they made a whole piece based on that idea. And that was premiered in our annual meeting. It was also a fantastic idea. So that can be also, data can be also translated into movement. Another lampshade of the Berlin Science Week this year was the idea of experiencing the idea of superposition and measurement collapse in quantum physics. So the fact that you can be at 1 and 0 at the same time, and then when you measure, it gets to 1 or it gets to 0. And I don't have the video, unfortunately, but basically her light is flickering. When you're seeing it from the distance, the light is flickering. And as soon as you get closer, there's a sensor that's a form of the eye of eyes at the top, and detects your movement. And when you get closer, it just says collapse, and then gets to 0 as enlightened, or no, as switched off, or 1 as enlightened. And then you go again far away, and it starts running again and being in superposition again. So that's an interactive experience of superposition and measurement collapse example by Maria Spetman. We can also tell the stories in the other direction. So we also regularly hold an art and science contest that also encourages our young researchers to think about their data in a different way. And so instead of taking a random data and transform it, there are also some data that you can have as it is, but make them tell different stories. So for example, here Ariana Nigro and Nicolas Forer had, I think, made a measurement of different materials, I think, on this surface, and then they tweak the colors of this measurement so it looks like a flamingo, and then sold the story about a flamingo instead of material measurement, or still as a material measurement. Here we can, like, if you look at this sample, it looks like a house with flowers, and then this measurement on the right by Luigi Ruggiero it looks like angel wings. So you can also, when you have data that also reminds you of something else, you can also make a story about data itself. Looking for talents. So like to do all of these projects, there's nothing I do on my own here. It's always with scientists, or there's always a team here, or sometimes they work on their own, but most of the time it's as a team. And And I found it really important to talk to the scientific community around me, because a lot of scientists are really interested in some kind of art at many levels and at many ways, from enthusiasts to semi-professionals. So Ilan Bouquet, the dancer, is a semi-professional, but we would never have done this project if we wouldn't have talked at one point. So I think fostering a communication with researchers in general, you can actually assess who is interested in doing what and encourage them to develop their own art and science projects, maybe also make or enable projects, and then get in your team people who you know are going to be interested. Listen to them, so that if they have a special interest, you have more chances to have them on your project as well. So I found it pretty useful to know also sometimes more personally the researchers and talk to them regularly, so that I kind of know who is interested in what and how. And so it helps for some projects to go directly to the scientist, or to make projects that I know they would be interested in. Yeah, as I said, that's how this project actually happened. It was a first conversation maybe 2 years ago with Ilan, and I discovered he was a semi-professional dancer and he always wanted to do art and science. And we had a brief conversation and an idea about, oh, maybe we could do something like that. And then 1 year later, he came to me and he said, oh, actually, I really want to do it. And he did the whole thing. He developed the choreography. He recruited other researchers, actually, so beginners, actually, people who were in the network and were just interested in learning how to dance. And so they took part in the project and trained for several months, maybe 4 months. And that choreography, they also had a professional dancer with them. And Aripriya is also a very good dancer. And they all together brought up this piece at the annual meeting, and it was a fantastic piece. And I think everybody really appreciated it. And now we want to send them to some other events so that they can showcase their talent. And what's in it for the scientists? So I think it should be fun. So that's the first thing, because science communication can sometimes, unfortunately, at the time, scientists focus more on their research, and it's not yet too much democratized that science communication is also super important. And so most of the scientists do it on their free time, or not really as part of their full-time job. And so to encourage them to get in, I think it should be fun. And art and science can really offer that kind of fun aspect, because it takes them to do something that they don't do usually, and that's totally different in the way of expressing what they're doing. And yeah, when scientists told me that, I like the fact that I could make an outreach project writing something that did not have to make logical sense at first. And they can learn to talk about science in a different way, as I said, to develop science communication skills as well, so that can be used as workshops, and to encourage these skills to be developed in your institution or in your institution. And recently also, one of the scientists told me, oh, there's something I've learned. She was quite enthusiastic. She said, I learned how to make the audience feel my ideas. So feel, in her case, it was feeling how small things could be. And so she had made also an imagery comparing sizes, different scales of sizes with the scales of her sample, and she thought that yeah, through this project she could now have more understanding about how to make people feel an idea. And of course, a lot of them also told me it's good for the CV. People are more and more, even if science communication is not yet super democratized, still more and more asked, especially in teaching positions or in communication and in recruitment processes. And so I was asked directly, what is the last science communication project you worked on? Yeah, so these are frequently asked questions now. in job finding, actually through just doing science communication, some people in the team met each other and then got employed by one another. So that can also happen. And as I think the last part of this talk, I just wanted to talk a little bit about multidisciplinary projects. So how we did it here. And so we start because what I really like when we do a project together with the scientists, especially for the Berlin Science Week, where we have to bring an art and science installation as a team. For me, what worked the best so far is defining a project, a general frame for the project. So I have a budget, I have a space, I have transportability constraints. I have environmental constraints. Maybe it's super cold outside, maybe it's super rainy, I don't know. But and then I have to kind of frame it to have the first frame so that I don't go to the team and we start talking for a long time, because 6 or 7 people in a team, you can go into discussions quite long. But if I come with a set of like a first frame, then at least there's a part of the discussion that can be avoided, and that focus can be more on the ideas and less on the logistics of it, let's say. So for example, for this year, for the Berlin Science Week, it was like no shipping. We're not shipping to Berlin. It should be easily dismantleable. We're exhibiting in winter in 6 square meters and outside, and our budget is 2,000 francs, for example. And so I was like, okay, let's try to make lampshades. Because lampshade allowed me to have a space where they can be a coherent theme, so a teamwork, but also have each scientist designing their own lampshade. So in this way, people could really get into their own project as well and lead it as they wanted and put their own ideas into it, because that's also the idea. And of course, people in the team have differences in ideas, project management, and also aesthetics, right? Art is subjective, so it allows this kind of flexibility. If everyone has something individual to make, they can really pour their ideas into it and nobody else. Of course, we always have meetings where we help each other, we comment, etc., but it's still their art piece. And as I said, art is very individual. Then I prefer focusing on the concept and the intentionality. I want them to have an intention behind what they're doing and a concept, more than a certain aesthetics, because I think what is aesthetically pleasing is actually very different for people, and I think that's not very much the goal here. And as an artist or a designer, I act more in that as a guide in this kind of projects. If they need me, we can discuss things, and if they don't, it's fine. And we always meet as a team anyway. And I notice also, if it's possible, if I have people from different field of competencies and I see that they can help each other, I ask them to talk to each other and interact. And this year that ended up in that general theme, look closer. So each of our lampshade was actually interactive, and the public had to go and actually look closer and to experience each of the lampshades. So this was part of the team. This one I explained already. Renato's work was about decoherence, so that synchronization at first, and then noise happens, and then everything gets desynchronized. So that's embodying the phenomena called decoherence in quantum physics, when information in a qubit is lost. Abic had a superposition, so here we don't see it very well. Maybe we see it better on the green in the green strip here, where he had the superposition of 2 cats, and with glasses of different colors, you could separate the 2 cats. And Young, I didn't have photos of hers, but was she had actually so different images with embodying different sizes and different scales of her own samples. So her own sample, and then an ant, an elephant, and etc. And then she had questions, and she had written her answers with the tool that she uses in the lab to make chips. So she had used electron beam lithography to write the answers in a very small scale, so that people had to get their magnifying glass to actually look at their answer, and that's how they could feel like getting to a smaller size. Yeah. So now the last breakout room. I know in 10 minutes it's not going to be much, but maybe we can collaboratively brainstorm an art and science piece. So if your space is the same as we had, it's a tiny wooden hut outside, and you can use nails and drills in it. And the public can cannot enter, but the hut, but only see it coming from the outside. And your budget is around $3,000. Maybe Drew can imagine a tiny project that uses art and science, just having a small concept, maybe a medium and a message. But yeah, maybe let's try this out. Thanks for all the discussions. I think I'm gonna jump to conclusion. I think I think we've discussed and see the emotional nature that puts everyone on the same footing, and that with art we can feel more also, and it's a fantastic entrance door for discussing about science. And I think I'll stop there because if you have questions, I'm sorry I'm a little late, I think, but I want to give the opportunity to ask. Thank you so much. Also, that's all the teams. That's very important too. So my boss, Marina Longobardi, who's the head of all of this, but also colleagues and all the teams that have worked on all these really cool projects.